Dear students, let us continue our discussion on continuity. Let's have a look at the next question. Question number 108. If the function f of x is equal to 1 minus cos 4x by x square when x is negative, a if x equal to 0 and root x by root 16 plus root x minus 4 if x is positive is continuous at x equal to 0, then a is equal to. See, here they have given that the function is continuous at x equal to 0. If the function is continuous at x equal to 0, then what is the value of a? If it is continuous at 0, means left hand limit must be equal to right hand limit must be equal to f of 0. Right? So now we are not proving that it is continuous. So you need not find out left hand limit as well as right hand limit. You take any one of those, that's enough. I will go with the left hand limit. I will just find out left hand limit. Left hand limit is limit extends to 0 minus f of x. That's equal to f of 0. Right? Of course, it is also equal to the right hand limit, which we don't have to prove. So now limit extends to 0 minus x is approaching 0 from left side, means x is less than 0. When x is less than 0, the function is defined as 1 minus cos 4x divided by x square. This is equal to f of 0. F of 0 is 3. If I directly apply the limit here, we get 1 minus cos 0. Cos 0 is 1, 1 minus 1 is 0. 0 by 0 is an indeterminate form. So now, I use L'Hospital's rule. Derivative of 1 minus cos 4x, that will give you 4 into sin 4x. Derivative 1 is 0, derivative of cos x is minus sin x. So derivative of cos 4x is minus sin 4x into 4. So minus into minus plus 4 sin 4x. Divided by the derivative of x square. Derivative of x square is 2x. Okay. So now this is equal to a. Here sin 4x by x, its value is 4 because I will multiply and divide by 4. So its value is 4. Here 4 by 2 is 2, 2 into 4, that is a. So a is equal to 8, which is the first option. Next question. If the function f of x equal to k cos x by 5 minus 2x when x is not equal to pi by 2, and if it is 3 when x is equal to pi by 2, and this function is continuous at x equal to pi by 2, then what is the value of k? Here they have given that the function is continuous at x equal to pi by 2. So now we don't have to find out what is left hand limit and right hand limit, because that is not necessary. To the left side of pi by 2 and to the right side of pi by 2, f of x is defined in the same way. So I will directly go for limit extends to pi by 2 f of x is equal to f of pi by 2. Okay. So now limit extends to pi by 2 f of x. F of x is k cos x divided by pi minus 2x. That's equal to f of pi by 2. F of pi by 2 is 3. If I directly apply the limit here, k into cos pi by 2. Cos pi by 2 is 0. Denominator pi minus 2 into pi by 2. That is also 0. 0 by 0. So immediately we can go for L'Hospital's rule. So this will give you minus k into sin x divided by minus 2 is equal to 3. Apply the limit as extends to pi by 2. So sin pi by 2 is 1. Hence we get k by 2 equal to 3. That will imply that k is equal to 6. K equal to 6 is the third option. Then 111. F of x over step x is continuous on. It is continuous. You know, step x is discontinuous at all integers. Everywhere else it is continuous. Therefore, this function is continuous on r minus z. Fourth option. A function f of x is defined as ax minus b when x is less than or equal to 1, 3x when x is less than 1, greater than 1 but less than 2, and bx square minus a when x is greater than or equal to 2 is continuous at x equal to 1 and at x equal to 2. Then what are the values of a and b? Okay. So here in our previous class I gave you one shortcut. Ax minus b when x is less than or equal to 1, 3x if x is between 1 and 2, and bx square minus a when x is greater than or equal to 2. So first I will take continuity at x equal to 1. Their left hand limit will be equal to, put x equal to 1 here, we get a minus. Right hand limit, put x equal to 1 in this, we get 3. Since it is continuous at x equal to 1, I can directly write a minus b is equal to 3. Now you verify the options, you check in which option do we have a minus b is equal to 3. Look at first option 5 minus 2, that is 3. So first option may be the answer. Second option is 6 minus 3, that's also 3. Third option is 7 minus 4, again that is also 3. And fourth option 8 minus 5, that is unfortunately that is also equal to 3. So from this we can only say that among the 4 any one of them is the answer. We cannot come to any conclusion now. Okay, see why I am saying this, because in our exam you may get a question where the options, among the 4 options only one option is giving you that a minus b is equal to 3, then you can directly write that as the answer. But here we are unfortunate that all the 4 options is giving us a minus b is equal to 3 only. So therefore I will consider continuity at x equal to 2. They have given that at 2 also it is continuous. So I put x equal to 2. Say for 2, the left hand will put x equal to 2 here, we get 6. Put x equal to 2 here, we get 4b minus a. Right? So 4b minus a is equal to 6. I'll add these two equations. Here a minus b is equal to 3. Let me call this as equation 1 and this as equation 2. I'll add these two equations. When I add them, a gets cancelled. 4b minus b, that is 3b. 3b is equal to 9. Therefore, b is equal to 3. b equal to 3 means a must be equal to 6. So, second option is the right answer. Then 114, f of x equal to, this is continuous at x equal to 2, then what is f of 2? They are asking. F of 2 is equal to k, they have given. What is the value of that k? They are asking. F of x is defined as x cube plus x square minus 16x plus 20 divided by x minus 2 whole square when x is not equal to 2. And it is k when x equal to 2. Since the function is continuous at x equal to 2, we can write limit x tends to 2 f of x is equal to f of 2. Limit x tends to 2 f of x equal to f of 2. So limit x tends to 2 f of x. Write down what is f of x. X cube plus x square minus 16x plus 20. Divided by x minus 2 whole square. Okay, that's equal to f of 2. Now, I'll put x as 2 here. 2 cube, which is 8, plus 2 square, 4. 8 plus 4, 12. Minus 32. 12 minus 32 will give you minus 20 plus 20. Numerator is 0. Denominator obviously is 0. So, as soon as you see 0 by 0, immediately we will jump to L'Hospital's rule. That is 3x, you differentiate it, we get 3x square plus 2x minus 16 divided by 2 into x minus 2. Now you put x equal to 2. Numerator is 2 square, that is 4. 3 into 4 is 12 plus 2 into 2 is 4. 12 plus 4 is 16 minus 16, 0. Denominator also 0. 0 by 0 is an indeterminate form. So we get limit x tends to 2. Directly apply the limit, you are getting 0 by 0. So I am using L'Hospital's rule again. That will give you, if I differentiate it, I am getting 6x plus 2 divided by 2. Put x equal to 2. We get 12 plus 2, 14 by 2. That's equal to 7. Third option. Then 115. F of x over mod x plus mod x minus 1 is continuous at where it is continuous. You look at the graph of mod x. Mod x is continuous everywhere, and similarly mod x minus 1. This is the graph of mod x minus 1. Mod x minus 1 is also continuous everywhere. So continuous everywhere means continuous everywhere, right? So third option is the answer. Remember, mod x is not differentiable at 0, and therefore similarly mod x minus 1 is not differentiable at 1. But as far as continuity is concerned, mod x is continuous everywhere. We can also say modulus of x minus a is continuous everywhere. Then 116. F of x equals step x plus mod x minus 1. Okay. See, now we have to test the continuity of this function at different points. Mod x minus 1, you don't worry about it, because you know that mod x minus 1 is continuous everywhere. So the only thing that we need to bother about is about step x. So mod x minus 1 is continuous everywhere, and step x is continuous on r minus z. As you know, it is discontinuous. Step x, the greatest integer function, is discontinuous at integers. Okay. So at all integers, step x is discontinuous. Sum of two functions will be continuous if both are continuous at that point. At any point, if I want to test the continuity of sum of two functions, say f of x plus g of x, I want to know where f of x plus g of x is continuous. So I have to see where f of x is continuous and g of x is continuous. At a point, if both are continuous, then it is continuous. If one of them is continuous and the other one is discontinuous, then their sum is discontinuous. Okay. So now this is continuous, no problem. Therefore, this function will be discontinuous whenever step x is discontinuous. Step x, you know, it is discontinuous at all integers. Therefore, this function is discontinuous at 0 and 1. I mean, not only 0 and 1, it is discontinuous at all integers. But among the given options, fourth option is the correct answer. Then 190. If f of x is equal to root of 1 plus kx plus minus root of 1 minus kx by x for x between minus 1 and 0, and 2x square plus 3x minus 2 for x between 0 and 1 is continuous at x equal to 0, then k is equal to. Okay. It is given that the function is continuous at x equal to 0. Therefore, we can write limit x tends to 0 f of x is equal to f of 0. So limit x tends to 0 f of x. Okay. So limit x tends to 0 f of x. Here I have to find out left hand limit as well as right hand limit, because to the left side of 0 and for the right side of 0, function is defined into into different ways. So I will write like this: limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x. Okay, that's also equal to f of 0. Limit x tends to 0 minus x is approaching 0 from left side. There it is defined as root of 1 plus kx minus root of 1 minus kx divided by x. That's equal to right hand limit is limit x tends to 0, x is approaching 0 from right side. There the function is defined as 2x square plus 3x minus 2. Apply the limit as x tends to 0. So when I apply the limit as x tends to 0, this would be 0 by 0. So if it is 0 by 0, I can go for L'Hospital's rule. Limit x tends to 0, if I differentiate this, I am getting 1 by 2 root of 1 plus kx into k minus 1 by 2 root of 1 minus kx into the derivative of 1 minus kx, which is minus, divided by 1. On RHS, in the right hand limit, when I put x as 0, I am getting minus 2. Right hand limit is minus 2, and f of 0 is also minus 2, because at 0 the function is defined like this: put x equal to 0, we get minus 2. Okay. Here, if we apply the limit now as x tends to 0, we are going to get k by 2 into root 1. Root 1 is 1, k by 2 here. It will be minus into minus plus k by 2 is equal to minus 2. K by 2 plus k by 2 is equal to minus 2. K by 2 plus k by 2 is nothing but k. So k is equal to minus 2. Minus 2, third option. Then 120. Given that the function is continuous at x equal to 2, then k is equal to. The function is continuous at x equal to 2, then what is k? So, continuous at x equal to 2. I can say left hand limit is equal to right hand limit is equal to the functional value. Or else, say, f of x is equal to, we have 2x minus 1 when x is greater than 2, k when x equal to 2, x square minus 1 when x is less than. So, for left hand limit at 2, put x equal to 2 here. We get 2 square minus 1, 4 minus 1, 3 is equal to k. That's the answer, k is equal to 3. Then for right hand limit, here if I put x equal to 2, I am getting 2 into 2, 4 minus 1, 3. So, k is equal to 3. First option is the answer. Okay. So, now let us go to level 2. Okay, students, now we will discuss level 2 problems. The question number 1, limit extends to 1, summation k from 1 to 200, x power k minus 200 divided by x minus 1 is equal. Limit extends to 1. Limit extends to 1. Summation x k from 1 to 200 x power k, sigma k equal to 1 to 200 x power k. Let us go on putting values for k starting from 1 till 200. Okay. So what do we get? X power 1 plus x square plus x cube etc. till x power 200 minus 200 divided by x minus 1. Okay. So there they have given in terms of sigma summation. So that if I simplify, I am going to get x plus x square plus x cube plus x power 4 and so on till x power 200. Oh. Now I will apply the limit. If I apply the limit as x tends to 1, I am getting 1 plus 1 plus 1 etc. How many times? So we are starting with x power 1, then x square, then x cube, x power 4 etc. till x power 200. So there are 200 terms starting from x power 1 till x power 200. There are 200 terms. Now when I apply the limit as x is equal to 1, every term will give us 1. X power 1 is 1, 1 power 1. X square is 1 square, that is 1. X cube is 1 cube, that is 1. And the last term is x power 200, that is 1 power 200, which is also 1. So 1, 1, 1, 1, this sum will give us 200. Right? 1, 1, 1, 200 times, that sum is 200. 200 minus 200, we get 0. Denominator also 0. So when we see 0 by 0, we will go for L'Hospital's rule. Limit extends to 1. If I differentiate now, I am getting 1, derivative of x power 1 is, x power 1 is nothing but x, its derivative is 1, plus 2x plus 3x square, etc. The derivative of x power 200 is 200 into x power 199 minus the derivative of 200, derivative of 200 is 0 divided by derivative of x minus 1, which is 1. Oh. Put x equal to 1 now, apply the limit as x tends to 1. When I put x equal to 1, I am getting 1 plus 2 plus 3 etc. till 200. 1 plus 2 plus 3 up to 200. So we have the formula 1 plus 2 plus 3 up to n. 1 plus 2 plus 3 up to n. You know the formula, that's equal to n into n plus 1 by 2. So this is equal to 200 into 201 divided by 2. That's equal to 100 into 201, which is equal to 20,100. 20,100, which is the fourth option. Okay, let's look at the second question. Limit extends to 0, x into 1 minus root 1 minus x square divided by root 1 minus x square into sin inverse x cube is equal to. Okay. Limit extends to 0. If I directly apply the limit, I am going to get this is 0 into that will also be 0 only. This is 1, this is 0. So 0 by 0 you get indeterminate form. But now don't go for L'Hospital's rule. Why I don't advise L'Hospital's rule for this problem is because I have to use product rule here, product rule of differentiation. Here also use product rule. Then the derivative of sin inverse x cube will be 1 by root of 1 minus x power 6 into 3x square, etc. It is very complicated. So don't go for L'Hospital's rule. Instead, let us see what else we can do. 1 minus root of 1 minus x square divided by root of 1 minus x square into sin inverse x cube. Okay. Say, you know one formula. You know several formula. Among them, one of them is limit extends to 0 sin inverse x by x is equal to 1. Do you know this formula? Limit extends to 0 sin x by x is equal to 1. That everybody knows. But you know this formula also. Limit extends to 0 sin inverse x by x is equal to 1. Do you know? I think I have mentioned this earlier during synopsis. Okay. Anyway, I'll just recall this. This is one formula. Similarly, limit extends to 0 tan inverse x by x is also equal to 1. If you are in doubt, then you can use L'Hospital's rule here. Derivative of sin inverse x is 1 by root of 1 minus x square. Divided by derivative of x is 1. Now apply the limit as x tends to 0. You will get 1. Right? So, this limit is equal to 1. This formula we know. Now I want to use this formula. Limit x tends to 0. Sin inverse x by x is equal to 1. Look here we have sin inverse x cube. So when I have sin inverse x in the numerator, I want x in the denominator. So here I have sin inverse x cube in the numerator, or rather denominator in this case. So its denominator we want x cube. Okay. So what do? I divide this by x cube. Then to compensate it, I multiply by x cube. Okay. Now as x approaches 0, this factor sin inverse x cube by x cube becomes 1. Okay, so that I don't have to write that in the next step. Okay. Then limit extends to 0. Here x gets cancelled. We'll have 1 minus root of 1 minus x square divided by root 1 minus x square into x square. One of those x we have cancelled, x square is remaining. Now when I apply the limit as x tends to 0, still I am getting 0 by 0 only. But even now also using L'Hospital's rule is not a good idea. Okay. So I will multiply and I will rationalize this. I will multiply and divide by 1 plus root 1 minus x square. Here we have 1 minus root 1 minus x square. I will multiply and divide by 1 plus root 1 minus x square. Multiplying and dividing by 1 plus root of 1 minus x square. That's equal to limit extends to 0 a minus b into a plus b. A minus b into a plus b. That is a square minus b square. So we get 1 minus of 1 minus x square divided by root of 1 minus x square into x square into 1 plus root of 1 minus x square. Okay. In the numerator, we get 1 minus 1 plus x square. 1 minus 1 plus x square. 1 gets cancelled. X square will remain. That x square, this x square gets cancelled. So after simplification, we will be left with limit extends to 0. 1 divided by root of 1 minus x square into 1 plus root of 1 minus x square. Root 1 minus x square into 1 plus root of 1 minus x square. Now apply limit as x tends to 0. When I put x as 0 here, we get 1 by 1 minus 0 is 1 into 1 plus 1 minus 0 is 1. Okay, so this will give you 1, that will give you 1. 1 plus root 1 minus x square. Sorry, I am putting x as 0, right? So when I am putting x as 0 means 1 minus 0 is 1, 1 plus 1, that will give you 2. So the answer is 1 by 2, which is the second option. Next, limit extends to 1 by 2, 8x minus 3 divided by 2x minus 1 minus 4x square plus 1 divided by 4x square minus 1 is equal to. Okay, let us see what happens if we directly apply the limit. If I directly apply the limit, put x as 1 by 2 here, 8 into 1 by 2 will give you 4. 4 minus 3, so numerator is 1, denominator is 0, 1 by 0, it tends to infinity. So first term will tend to infinity. Minus, look at the second term, 4 into x square, I am putting x as 1 by 2, so x square is 1 by 4, 4 into 1 by 4, that will be 1, 1 plus 1 is 2. Denominator is 4 into 1 by 4, that is 1, minus 1, 0, 2 by 0, that is also tending to infinity. So this is of the form infinity minus infinity. Infinity minus infinity. When you get infinity minus infinity, what do we do? Don't cancel infinity and infinity, so we will get the answer as 0. No, that will be the marks provided there is no negative ones. Okay. So, infinity minus infinity is one of the indeterminate forms which cannot be written as 0. Okay. Let's see. See, it is becoming infinity because of which factor? Because of 2x minus 1, right? That 2x minus 1 is sitting in the denominator. That is the factor which is causing that denominator to become 0. So we should try to eliminate that 2x minus 1. Okay. So you will get the second term here, 4x square minus 1. That 4x square minus 1 can be written as 2x plus 1 into 2x minus 1, right? 4x square minus 1 is nothing but 2x plus 1 into 2x minus 1. And then I will take 1 by 2x minus 1 as a common factor. Okay. So I will write the given problem as limit extends to 1 by 2. 1 by 2x minus 1. Here 8x minus 3 will remain. I am taking 2x minus 1 out. Minus, here what will remain? 4x square plus 1 divided by, see that 4x square minus 1 I have factorized it as 2x plus 1 into 2x minus 1. In that I have taken 2x minus 1 out, 2x plus 1 will remain. I think you have understood. Okay. Then limit extends to 1 by 2. You retain this here only, 1 by 2x minus 1. Here I will take the LCM. LCM is 2x plus 1. This will become 8x minus 3 into 2x plus 1 minus of 4x square plus 1, which will become minus 4x square minus 1. That's equal to limit extends to 1 by 2. Then you can take it inside. Here you multiply and simplify it. We get 16x square plus 8x minus 6x minus 3 minus 4x square minus 1 divided by 2x minus 1 into 2x plus 1. That will give you 4x square minus 1. I will continue here. That's equal to limit extends to 1 by 2. Here on simplification, 16x square minus 4x square, we get 12x square. Then 8x minus 6x is 2x. After that, minus 3 minus 1, which is minus 4, divided by 4x square minus 1. Now if you apply the limit, let us see what happens. If I put x as 1 by 2, I am getting 12 into 1 by 2 whole square, that is 12 into 1 by 4, which is 3, plus 2 into 1 by 2, that is 1, 3 plus 1 is 4, 4 minus 4, that is 0. Numerator is 0, denominator 4 into 1 by 2 whole square, that is 1, minus 1, 0 by 0, an indeterminate form. Okay. Now we can use L'Hospital's rule when it is of the form 0 by 0 or infinity by infinity. L'Hospital's rule can be used. Now if I differentiate this, I am going to get 24x plus 2 divided by 8x. Okay. Put x equal to 1 by 2 now. Apply the limit. Put x equal to 1 by 2. 24 into 1 by 2 will give you 12. 12 plus 2 is 14. Divided by 8 into 1 by 2. 8 into 1 by 2 is 4. So 14 by 4. What do we do? Shall we cancel 4 4? No. 2 sevens are 2 2s are 7 by 2 is the answer, which is the first option. Okay then. Let's have a look at the question number 5. The quadratic equation whose roots are L and M. Okay. Whose roots are, that R is missing. Whose roots are L and M. Where L is equal to limit theta tends to 0, 3 sin theta minus 4 sin cube theta by theta. Okay. Here there is a printing mistake, typing mistake rather. 3 sin theta minus 4 sin cube theta. Make it as 4 sin cube theta. L is limit theta tends to 0, 3 sin theta. L right here. L is equal to limit theta tends to 0, 3 sin theta minus 4 sin cube theta divided by theta. This is L. And M is limit theta tends to 0, 2 tan theta divided by theta into 1 minus tan square theta. Okay, look here. We are asked to form a quadratic equation whose roots are L and M, where L is limit theta tends to 0, 3 sin theta minus 4 sin cube theta by theta. M is limit theta tends to 0, 2 tan theta by theta into 1 minus tan square theta. Okay, did you understand the question? So here we are asked to find a quadratic equation whose roots are L and M. So, but what are L and M? L and M are equal to this. So, first you have to get the value of L and M. After getting the value of L and M, you form a quadratic equation having L and M as its roots. Okay. So, now let me concentrate on the L. Limit theta tends to 0. 3 sin theta minus 4 sin cube theta by theta. 3 sin theta minus 4 sin cube theta can be written as sin 3 theta. 3 sin theta minus 4 sin cube theta is sin 3 theta by theta. Sin 3 theta by theta as theta tends to 0 will be equal to 3. Then M is limit theta tends to 2. Sorry. That's the value of M actually. Okay. So limit theta tends to 0. Look here. 2 tan theta by theta into 1 minus tan square theta. 2 tan theta by theta into 1 minus tan. Leave this theta. Look at this. 2 tan theta by 1 minus tan square theta. That is nothing but tan 2 theta. You know that formula. So we can write this as tan 2 theta divided by theta. What is the value of this? Limit theta tends to 0. Tan 2 theta by theta is equal to 2. So L is 3 and M is 2. We want a quadratic equation whose roots are 3 and 2. If alpha and beta are the roots of a quadratic equation, then that quadratic equation can be written as x square minus of alpha plus beta into x plus alpha beta equal to 0. So x square minus sum of these two, that is 5x plus product of these two, 6. Or you already know, quadratic equation having 3 and 2 as its roots is x square minus 5x plus 6 equal to 0. First option. Okay? Okay, students, with this I will stop today's class. We will continue in the next class. Thank you.